All right, so we're continuing on to talk more about finding the domain of a function. So we're doing some more examples here, and our first one is f of x equals absolute value of 3x minus 2. So again, we're asking ourselves, hey, do I have anything that will cause me to divide by 0? And the answer, of course, is that one is no, because I don't have any x's in the denominator. So am I going to take the square root of a negative number? That's the second thing to check. And the answer for that one, of course, is no, because we don't have any square roots. So this domain becomes very simple. It's going to be all real numbers. Or we can write all real numbers, except I can't spell. Or in interval notation, we can say negative infinity to infinity. It's all good. All right, so for our next one, we've got f of x equals 1 over x to the 4th. So we're going to check first is our divide by 0. And we look at this one and we say, you know what? If I try to plug in 0, I'm going to be dividing by 0, right? Because I would have 1 over 0 to the 4th. That does not exist. So we have got to throw out x equals 0. Is there anything else? There's no other factors in this denominator. There's no square roots, so we don't need to worry about that. So the only thing we have to throw out is x is not equal to 0. So in interval notation, we're going to say negative infinity to 0, union 0 to infinity. But, you know, depending on what the problem asks for, if this were a paper test, I would say just write x not equal to 0. Now, the nice thing about domain is that you can often check your work by graphing, right? So we can pull this here. We're going to have, say, okay, let's just graph our y equals absolute value. Oops, I didn't get equals, I got a minus of 3x minus 2. And we can see that there's really not any issues here. This function goes on and on and on forever. There's no values of x that we can't put in. Now, if we do the 1 over x to the 4th, I'm going to zoom in on this one. So I'm going to right-click and say zoom to fit. That was not great, but let's do this. Let's do this. There we go. Okay. So we can see here that this graph is kind of exploding, taking off in the y direction. Although I'm going to, let's go back to settings here and do our y max as like 100, and our minimum is like -1, and let's go -10 to 10. -10 to 10, yeah, that should be okay. And you can see the same sort of thing here, right? So it's undefined, it's got a vertical asymptote happening at x equals 0, but that's the only place that this function does not exist. So let's take this back off and continue on. So just a couple more examples, and then I'll throw you in the deep end, right? We've got f of x equals 8 over x plus 4. And so obviously we've got x's in the denominator, so we do need to worry about division by 0. That didn't even go the right direction. Let's try this again. So 1, we need to worry about divide by 0, right? So we need the denominator not to equal 0. So x plus 4 can't be 0. So this is a good way to write it, is just take the whole denominator and say, well, I can't have that equal to 0, and solve for x. So if I subtract 4 from both sides here, I actually have my answer that x can't be -4. So we've got to throw that out, and if we write this in interval notation, negative infinity to -4, union -4 to infinity, and everything here is parentheses. All right, so for this last example on this page, we're going to say, okay, is there anywhere where I'm going to potentially divide by 0? We're going to say there's no x's in there's no denominators here. So there's no worries about divide by 0. And there's no worries about square root of a negative. So this is another one that has our domain being all real numbers, i.e. -infinity to infinity. All right, so we'll take a pause here before we go on to the next set of examples.